Hello everyone. So now we are going to talk about, we already discussed what is the tension formula, what is the velocity equation. At each point we can find out general equation also we derived. Now I would like to apply some conditions. So in those conditions, like this particular vertical circular motion will satisfy some sort of things. For example, it can actually reach at the point B, or it can reach at the point C. It can complete the loop. It can have oscillations, etc., etc. So in any condition, see, the fundamental understanding is we have the tension formula, and we know that by intuition also we know that if the body's tension becomes zero, or like if it comes to zero at any point, it will come back, right? For example, if it goes to the point C, and where the tension is zero, suppose, then what happens? It will go down. If necessary tension is required to move on a vertical circle. So exact thing, I hope you understood. That is, the tension must be more than or equal to, or tension at a C should be greater than or equal to zero. Then we can complete the loop. So here I am discussing. So it's a condition for completing the loop or looping the loop. So this is what is the thing. So at a point C, the tension is supposed to be greater than or equal to zero. So now coming back to the point, if tension is greater than or equal to 0, we already have the equation for tension. So what is that? M by R into U square plus RG minus 3GH. And at point C, so at point C, what would be the value of tension? So you know that M by R into U square plus RG minus 6, like you know that it is H is equal to 2R, right? So 6GR. So this will be the formula, or this I would be writing this as GR. So plus GR minus 6GR, of course this is minus 5GR. So it would be the tension at C is equal to M by R into U square plus GR, or I can write directly minus 5GR minus 5GR. This is the tension. We already did it. So this tension must be greater than or equal to 0 in order to have the complete loop. Or if you want the looping the loop condition is this must be greater than or equal to 0. Let me assume that it is equal to 0. Suppose if it is equal to 0, so then what would be the scenario? So mu square divided by r minus mg 5mgr, right? 5mg r get cancelled, is it should be equal to 0. What does that mean? Which implies I can cancel. U square divided by r is equal to 5g. Or what is u square? U square is equal to 5gr, or u is equal to, the minimum value of u is equal to root 5gr. So this is the idea which we have. So the thing is, like, the minimum value of initial velocity, you can see the minimum value of u is supposed to be root 5gr. If you give root 5gr, then what happens? It will reach to the maximum point and we get the complete loop. That has to be the minimum value. Any value which is greater than root 5gr is perfect. I hope you understood that particular thing. So now if you give root 5gr, you can understand that I want to find out what would be the velocity at this point B. All right. I want what would be the velocity at C. So it is very clear that, so I'm going to find out the velocity at point B. We know that what is the formula? Root of u square minus 2gh. So which is equal to root over u, how much is u square? That is 5gr minus 2gh is r. At a point B, you can understand. Look at this, where how much is h? H is r. So this is equal to root 3gr. So it is very clear that if you give initial velocity root 5gr, the velocity at a point B, it would be root 3gr. And again, what will be the velocity at point C? So you can see that velocity at C will be root of u square minus 2g into 2r. So apparently this is equal to root 5gr minus root 4gr, that is equal to root gr. So the idea is, again I repeat, so the velocity at a point, the maximum point will be root gr. The velocity at the midpoint between A and C will be root gr. So I think it is pretty clear right now. So just imagine I'm giving root 5gr at the bottom. So what's going to happen? So I'll be getting a velocity at this point. What will be that? Root 3gr. And I'll be getting a velocity at this point, root gr, and again it will be coming back with the velocity. Again it will be coming back, it will be coming back with a velocity root 3gr, and again it will be root 5gr. So this is what is going to happen in the case of a vertical circular motion, provided it's an ideal scenario. So that is the thing, and I hope you understood that part. And it's not difficult at all, it's very easy part. All right, so now we will meet the other conditions as well. We have to discuss about the oscillation, the maximum oscillation up from B to D, and then we have to discuss other parts as well. Okay, so we'll meet in the next video. Thank you.